Hello, math students. We are still working in Module 1, Ratios and Proportional Relationships, and the title of this lesson is Ratios of Fractions and Their Unit Rates, right here. Ratios of Fractions and Their Unit Rates. Our goal for today is we are going to learn how to determine the unit rate using fractions. The question that I want you to be thinking about is, how do you find the unit rate when the x value and the y value are fractions? For some reason, my little e fell off. Okay, so let's read that again. How do you find the unit rate when the x value and the y value are fractions? Okay, so the way to go about figuring this out is we need to do a little bit of a review. And so in our opening part of our lesson today, we're working on things to remember. So a quick review. The first thing that I want to talk about is remembering how to find a common denominator. So when you are dividing fractions by fractions, one of the easiest ways to do it is to identify a common denominator. Right now, as you see in these two fractions, your denominators are not the same. So one of the things that we can do to make this process very easy is we can make equivalent fractions so that they have the common denominator. And since one denominator is 2 and the other denominator is 4, what comes to mind for me that is showing that is the easiest is let's convert 1/2 into something fourths, because 4 is the same as 4. So the process of doing this is we just ask ourselves that infamous question that we've been using since we started is, how do I get from 2 to 4? What mathematical operation could I do that changes 2 into 4? And primarily we're remembering that we're using multiplying and dividing. So to myself, I say, okay, in order to get from 2 to 4, I need to multiply 2 by 2 in order to get 4, because 2 times 2 equals 4. And then I have to remember the rule of what you do to one side, you have to do to the other. So 1 times 2 is 2. So now I know that 1/2 is exactly the same as 2/4. Okay, so that's not so hard. And then I ask myself on the next one, how did I get from 4 to 4? Absolutely right. All I did was multiply by itself 1. Okay, so I'm going to take 4 times 1, and I got 4. What you do to the one side, you have to do to the other. 3 times 1 is 3, and so that fraction didn't change at all. Okay, so now some of you are thinking, Mrs. Nelson, why are you going to all that trouble? Well, one of the things that makes division of fractions very easy is when you have the same denominator, now you can just do the beautiful rule of dividing straight across, because the parts of the fraction are exactly the same size. And so we're just dividing one fraction of an amount by another fraction of the same amount, and then we can just divide straight across. So we ask ourselves, what's 2 divided by 3? And the answer that you get for that is 2/3, or 2 divided by 3, right? And what's 4 divided by 4? That's 1, okay? And if you go back up into our goal, it says today we are going to learn how to determine the unit rate using fractions. And if you remember what unit rate means per 1. So in this problem right here, we have 2/3 per 1, which is what we were looking for, okay? And so our answer for this problem is 2/3, or 2/3 divided by 1, which is still 2/3. Okay, so now we're going to try another one and see if we can do the same process. So again, we're looking at our denominators. We have fourths and we have sixths. Okay, this one's a little bit more challenging, not too tough though. So we have to think to ourselves, what is a common denominator that 4 and 6 share? So automatically some of you are thinking 24, because 4 times 6 is 24. That's fine, you can do that. But I like to think of one that is smaller. And the one that comes to my mind that is smaller is, I'm going to say 12. Because I know that 4 goes into 12 evenly, and I know that 6 goes into 12 evenly. And so I know that 12 is a common denominator for those two. So again, I ask my question, how do I go from 4 to 12? Again, I know that 12 is larger than 4, so I'm going to be multiplying. and I know that 4 times 3 would give me 12, and I remember what you do to one side, you have to do to the other, and so I have 3 times 3 equals 9. So now I know that 3/4 is equivalent to 9/12. Okay, so that wasn't so hard. Now we're going to do the next one. Again, ask yourself, how did I get from 6 to 12? And that one's not bad, times 2, because I know my math facts. But what you do to one side, you have to do to the other. And 1 times 2 is 2. And 6 times 2 is 12. So now I know that 1/6 is equivalent to 2/12. All right, so now I have the problem set up, and this is easy as pie to do because now that I have a common denominator, I can divide straight across. So 9 divided by 2 is 9/2, or 9 divided by 2. 12 divided by 12 is 1. So my answer on this one would be 9/2 per 1. And again, I found my unit rate. Okay, so not so horrible. This is pretty simple if you can remember all the steps. Okay, so now let's try one more. So this time we have 5/7 and we have 1/2. So our denominators are not the same, so we're trying to find equivalent fractions to make them having common denominators so we can divide straight across. So I'm thinking to myself as I'm setting up my math sentence, what number do 7 and 2 share or have in common? And this one, there aren't any other smaller, so I'm just going to multiply them together, and 14 is the denominator. Okay, so I have 14 and 14 because I know 7 goes into 14. So again, I ask myself, how do I get from 7 to 14? I multiplied it by 2. What you do to one side, you have to do to the other. So 5 times 2 is 10. So now I know that 5/7 is equivalent to 10/14. Okay, that wasn't so bad. So now I'm going to do the next one. Ask myself the question, how did I get from 2 to 14? And I'm going to remember that I multiplied it by 7. So what you do to one side, you have to do to the other. So 2 times 7 is 14. 1 times 7 is 7. So now I know that 1/2 is equivalent to 7/14. And now, kiddos, I'm so excited because I have a common denominator, and so I get to divide straight across. So 10 divided by 7 is 10 divided by 7. 14 divided by 14 is 1. So my answer is 10/7 per 1. And remember, all 3 of these are unit rates because a unit rate means per 1. So this one is 2/3, this one is 9/2, and this one is 10/7. And now I have turned all of those into unit rates because they're all per 1. Per 1, per 1, per 1, per 1, per 1, per 1, and we're all good to go. Okay? So hopefully in 6th grade you were able to learn this process. If not, then I taught you something new. Now, some of you are thinking, okay, why is she doing that? Well, the reason I'm doing that is if we go back to our goal again, today we are going to learn how to determine the unit rate using fractions. You're going to have to be able to find unit rate by dividing a fraction by a fraction. And so this is a very good review. How do you find the unit rate when the x value and the y value are fractions? Well, I just showed you. So the number one thing to remember when you're trying to find unit rates when you have fractions is they must have the fractions, right, must have a common denominator. So important, having a common denominator, because when you find the common denominator, you automatically are finding per 1, which is your unit rate. Okay, so that's pretty good. All right, not so challenging. Some of you are like, oh my gosh, this is so hard because it's fractions. But it's not really if you just set it up. Find the common denominator and then you're good to go. All right, so let's try one. It says, try it. During their last workout, Izzy ran 2 1/4 miles in 15 minutes. Julia ran 3 3/4 miles in 25 minutes. Each girl thought that she was the fastest. who was the fastest? Okay, so our job in this task is to find out who was the fastest. And by figuring out who was the fastest, we have some tools that we could use to do that. And so the first thing that I would like you to do, if at all possible, is I would like you to set up the rate that you're going to be using, because if you set up the rate that you're going to be using, then you can figure out how to make this into a division problem. Okay, so the rate that we need to use is, it says Izzy ran 2¼ miles in 15 minutes. Okay, and Julia ran 3¾ miles in 25 minutes. So if we're remembering a quantity, and a quantity is the number attached to the unit of measure, so 2¼ miles, that's a quantity. 15 minutes, that's a quantity. 3¾ miles, that's a quantity. 25 and minutes is a quantity because you have a number attached to the units of measure. That's how you come up with a rate. So the rate that I think we're going to do is we're going to do miles per minute. That is our rate for each girl because that's what they're running. Okay, so we have miles per minute, and then specifically it says what is the rate for each girl. So I'm going to say this is for Izzy. Okay, so Izzy's rate is 2¼ miles per 15 minutes. So this one is miles and this one is minutes. And we got to get used to the fact that we need to label everything. So that's Izzy. Okay, and then we have Julia. And so we'll put Julia right here. Can you see that all right? So there's Julia. And Julia can run 3¾ miles in 25 minutes. Okay, so that's Julia's rate. So we have Izzy's rate right here, we have Julia's rate right here, and now we're going to use a double number line. Hopefully you guys remembered what a double number line is. So the first thing that I want to do, I'm going to actually switch colors because I want to make sure that you can see. We're going to say that this is Izzy's double number line right here. And then we're going to say that this one is Julia's down here. Okay, you can't see Julia's. There's Julia's. All right, so on Izzy's double number line, remember double number lines are built that you put your rate on there. So we're going to do miles up here. We're going to do minutes down here. Okay, and then we ask ourselves some questions. For every 0 miles run, that means 0 minutes were used. Or for every 0 minutes used, 0 miles per run. There we go. I like that better. So it says for every 0 minutes spent or used, 0 miles are running. Okay, that's not bad. So then the next thing that it says is it gives us her rate is that it's 15 minutes. Okay, 15 minutes, and she runs 2¼ Well, if we go and we build our double number line so that each line represents a fourth, we could try that. So this would actually be 1/4 right here. This would be 2/4. This would be 3/4. This would be 4/4. This would be 5/4. This would be 6/4. 7/4. 8/4. 9/4. 10/4. 11/4. and 12/4. Now, some of you, in your mind, you could already be calculating. If you have 12/4, what you actually really have is you have 3, because 12 divided by 4 is actually 3. If you have 8 divided by 4, you actually have 2. If you have 4 divided by 4, you actually have 1, and then we have a 0 over here. Okay, so this really is just a big number line. Okay, and then the other thing that we needed to figure out, however, is it says that when she ran 2¼ and we said that each line is a quarter, so if we go over here to 2 and then one more is 2¼ it says, according to her rate, that that takes her 15 minutes. So right here is 15 minutes. Okay, which is kind of interesting because the question that I have for you is, how in the world are we going to figure out what 1 mile is? If it's 15 minutes clear up here, then what would 1 mile be? Because we're trying to figure out a way to compare their miles, and we can either do it per 1 mile, or we could go per 1 minute if you wanted to try that. So either way, we're going to have to figure them out, okay? So I'm going to go ahead and we're going to set up Julia's before we actually fill in anything else. So let's do Julia's, same thing. This is miles. This is minutes. Okay, and remembering the double number line is a really, really awesome tool. So when you go 0 minutes, you've traveled 0 miles, okay? And again, we're going to use quarters because if you look at Julia's up here says 3 3/4, so we're still working with quarters. The only problem is that it looks like that may fall off our graph, so we might have to add some more on there, which we can do. We'll work with it. So let's say that we're going to say that this is, or you know what I want to do? I'm going to put a little squiggly line right here. And whenever you do this on a graph, you have to put this squiggly line. And that means that we're skipping forward. So instead of having this only be 1/4, I'm going to say, let's make this right here actually be, let's make this 4/4. So we skipped that whole thing on our graph. So this one is actually a 1. So then this would be 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4, 12/4, 13/4, 14/4, 15/4, and we still fell off our graph, darn it. And so we'll have to go, but we'll see. We'll see if we have enough now. All right, so we're remembering that 4/4 is actually 1, right? And 8/4 is actually 2 because 4 divided by 4 is 1, 8 divided by 4 is 2, 12 divided by 4 is 3, and then that gives us an idea of what we have. And then if you go back to Julia's rate, it says that she ran 3 3/4 miles in 25 minutes. So now you're seeing why I did this little squiggle, because it's giving us extra room on our graph that we didn't have because we would have fallen off the page. So Julia actually ran 3, which happens to be right here, and 3/4. 1, 2, 3. We did fit in 25 minutes. So this is how long it took Julia to run hers, okay? So that's kind of helpful in us figuring it out. And so what we're trying to do is we're trying to figure out in 1 mile. So the 1 mile mark on both of the graphs is actually in a different spot. This right here says 1, so that's the 1 mile mark. This is the 1 mile mark. And so what we've got to be thinking is, how did we get, because remember, here's where Izzy is, how do we get from where Izzy is in 15 minutes down to 1? Okay? And so we're going to use the same thing we did on that other piece of paper, and hopefully I'm not confusing you too much, but we now know that Izzy, so go back to Izzy's graph up here, Izzy's rate says 2 1/4 in 15 minutes, right? And so what we're trying to find out is, how does she get, or how long does it take her to go 1 mile? Because remember, this is miles and this is minutes, right? So we want to know, how long does it take her to go only 1 mile? We know that it takes her 15 minutes to go 2 1/4 miles, but we want to know how long it's going to take her to go only 1 mile because we're doing a unit rate. So again, just like we said before, you have to ask yourself the question, how do you get from 2 1/4 to 1? Well, that's not too bad, because what we actually only have to do is we have to divide by 2 1/4. Okay, that's not so horrible. So you're going to take divided by 2 1/4 on the minutes. Okay. Okay, so that seems doable. All right, so here's the only thing that I would like to ask you is that this is 15 minutes out of an hour, right? And 15 minutes out of an hour is actually 1/4 of an hour, right? So you look at a clock, okay, and let's draw a clock so those of you who can see what I'm talking about. So here's a clock right here. Here's 12, here's 6, here's 3, and here's 9. Well, anybody knows that when you have a clock, 15 minutes is right here. So if it's 15 minutes to run 2¼ miles, how long out of the clock is that? That's really 1/4. So this little number right here, instead of being 15 minutes, we could actually say it's 1/4 because it's 1/4 of an hour. So the mathematical sentence that you're working on for Izzy is actually 1/4 divided by, and we learned that 2 and 1/4 is actually, look up here on your double number line, that's why we did it, 2 and 1/4 is actually 9/4. Oh, that's not bad. So look, everybody, we already have a common denominator. The common denominator is fourths, so now we get to divide straight across. So what is 1 divided by 9? 1/9. And what is 4 divided by 4 is 1. So in order to go 1 mile, so go back up here to the 1 mile mark on Izzy's, it takes her 1/9 of an hour. 1/9 of an hour. And if you figure out what 1/9 of an hour is, 1/9 of an hour, so you're going to take 1/9 times 60, because there's 60 minutes in an hour, and you get 60/9, which 9 can go into 66 times, right? Because that's 54. So 60 minus 54 is 6/9 left, right? So it takes her 6 2/3 minutes to run 1 mile. Wow, she's fast. 6 2/3 minutes. That's pretty crazy. Yeah, she is a fast girl. Okay, so now we know what Izzy does. So now our job is to do the same thing for Julia. Okay, so again, what was Julia's rate? Julia's rate is, so she's doing miles per minute again, right? And she had 3 3/4 miles in 25 minutes. So we're trying to figure out how long it would take her to run 1 mile, okay? And we did learn this one. This one was 6 2/3 minutes for 1 mile. So remember, this is mile, this is minutes, okay? Back over to Julia. So looking at what we have to do, well, if you have 25, so let's again go back to our clock, right? Here's our clock, here's 12, here's 3, here's 6, and here's 9, and 25 on there actually sits right there. So it would be 25 out of 60, right? And if you simplify that, you actually get 5/12. So this one, we're going to take 5/12 divided by, and then go back up here to where 3 3/4 was, which is 15/4, right? Okay, so here's our division problem. 5/12 divided by 15/4. Uh-oh, what are we missing? Our common denominators. So we've got to find common denominators. And if we remember from our other side of our paper, we go and say, oh, well, 4 goes into 12, so let's make 12 the common denominator. So 12 and 12. So now we ask ourselves, how did we get from 12 to 12 times 1? What you do to one side, you have to do the other. So that one would be 5/12, right? And then how do you get from 4 to 12? And you say times 3, so times 3, and 15 times 3. 3 times 5 is 15. Regroup the 1. 3 times 1 is 3 plus 1 is 4. So that would be 45/12. And then you divide straight across. Are you ready? 5 divided by 45 is 5/45. 12 divided by 12 is 1. And this one actually can simplify because 5 goes into 5 once. 5 goes into 45 9 times, and this is still 1. Oh my gosh, kiddos. Check it out. So here's where the 1 would be on Julia's. We just proved that Julia can run 1 mile in 6 2/3 minutes, because look, this was 1/9 up here, this is 1/9 down here, 1/9 is the exact same, so they both can run the same distance in the same amount of time. So we had to answer the question. The question said, who was the fastest runner? And what did you just learn by doing all of this math? They are exactly the same speed. Okay, so it's a tie. Okay, the girls tied. So the answer to this one is the girls tied. They run exactly the same speed. Okay, so that was kind of crazy. You're probably going, oh my gosh, Mrs. Nelson, I'm so overwhelmed. Don't be, okay? It's really not difficult as long as you can go slow and pay attention. All right, there's one more problem, and I know this has been a very long video, but I think it's been very helpful. One more problem. A turtle walks 7/8 of a mile in 50 minutes. What is the unit rate when the turtle's speed is expressed in miles per hour? So I'm going to help you with this one, okay? So I'm going to help you set it up, and then you're going to find the answer. So again, we're comparing miles to minutes, but then the answer wants us to do miles per hour. Okay, so here's how we set it up. We're going to do miles per hour because that's what it asks for. All right, so then we know that the turtle can go 7/8 of a mile on the top in 50 out of 60 minutes, right? Okay, so that's actually 5/6. So you can change that because if we divide 50 by 10, we get 5. If we divide 60 by 10, we get 6. And what you do to one side, you do to the other, so we're safe. So it would actually be 7/8 divided by 5/6. And that is what we're trying to do in order to get to 1 hour. So we're trying to get here, right? 1 hour. Okay, so if this is looking yucky to you, just ask yourself, how did you get from 5/6 to 1? Not so bad. We're going to divide by 5/6, right? Because 5 divided by 5 is 1, 6 divided by 6 is 1, 1 divided by 1 is 1. Well, what you do to one side, you have to do to the other. And so you have just created a problem just like the ones in the review. You're going to take 7/8 divided by 5/6. And you're going to follow the same pattern we did on the first section of our notes. Find a common denominator, right? So we're looking at 8 and 6. Try to find the smallest one you can find. Okay, you can multiply them together and get there, but try to find the smallest one that you can do. Okay, I'm going to give you a giant hint, and I'm going to say probably 24 is the smallest. Okay, and that's all I'm going to help you. You have to do this last part by yourself because I want to see if you learned anything. Okay, so what I'm going to be checking in your comp books tomorrow is to see that you found what the answer is per hour. Because by the time you get done, remember it will be per 1 because 24 divided by 24 is 1, and there's your per 1 or your per hour, right? Okay, so you can do that one. All right, going back to our goal for today. Today we are going to learn how to determine the unit rate using fractions. We totally did that. How do you find the unit rate when the x value and the y value are fractions? The answer to that is you find per 1. So you take one fraction and divide it by the other. One fraction and divide it by the other. One fraction divided by the other. And that takes you to per 1. As long as you find, what is our rule? A common denominator. The fractions must have a common denominator. And that's why I showed you how to do all of these, so that you could find your common denominator. All right, my darlings, that's all I have for you in this lesson. I'll talk to you soon. Bye.